Welcome to the part 6 of this series, and in this part we will be using NESTJS Framework, Typeorm Framework and Postgres to create our REST API. In previous parts we had been developing things from scratch, but in this case we will be using frameworks that will make things much easier for us. Moreover, we will be using vertical slice architecture to arrange or organize our files. Vertical slice architecture is another pattern that we can use for organizing our project files, irrespective of the programming language we are using. This architecture organizes the code by business concern rather than technical concern. In our clean architecture, we had been arranging or grouping our files based on their technical functionality, like data access, domain, application, or presentation. But in this case, we will be grouping them together based on the business feature like logging, like users management, and so on. In this diagram, you can see feature 1, feature 2, they represent the business concern, as I mentioned earlier. We can deploy these features as a collective monolith application, or we can deploy them individually as they contain all the required technical files to execute that particular business feature. The only drawback that could be possible is if the application is really large, then in that case there is a chance of duplication of a particular feature, and maintainability can become little harder if naming conventions and proper versioning is not maintained. Let's get started implementing VSA using NestJS. NestJS is a framework that helps us to simplify development of complex applications and reduce the amount of code we need to write. It supports TypeScript and a modular approach to develop the application, and more exactly the backend applications. It is inspired from front-end frameworks like Angular. It uses components of object-oriented programming, functional programming, and functional reactive programming. NestJS has a lot of libraries and it uses dependency injection mechanism built into the NestJS framework that allows us to inject different objects after creation into the constructor of other classes that require that object. The entire application is divided into hierarchy of modules. The topmost module is called the root module, and it can compose different other modules inside it. A module on the top hierarchy can use any module in the lower hierarchy. Each module is composed of providers, controllers, imports, and exports. We can create plugins, middleware, and other required artifacts. So here we are scaffolding a project using the NestJS, and I'm using npx directly from the internet with a project name after new, and need to install the required packages like at NestCLI 10.4.7. Then asking for the packages, package manager, I'm selecting the npm. This installation will take some time, and once it is done, you will be good to go with your project. Now we have generated the project using npx, and we can see different files here. Let's go through them one by one. If we go at the top, we can see the source folder. Then there are a lot of configuration files here. The first file that I would like you to visit is readme file, and it contains a lot of information about the framework. Here if you go, you can see that we have framework repository itself. So the first thing we need to do here is to update all the packages, and for that purpose we run npm install. We can see all the package.json, package.log configurations. Then we have the tsconfig The new configuration file here is related to NestCLI and it contains Nest framework configuration. We have git ignore. We're already familiar with that it will help us checking in our code and leaving behind all unnecessary files that we do not want to check into GitHub repository. Then we have eslintrc.js. We already used eslinting in our earlier episodes. If I go to the test, I have my test cases here, unit tests for my services and controllers. In this case, if I go here, there are four main files that are generated. Like one is app.service. Service class in NestJS encapsulate reusable logic such as data access, business rules, or external API interactions. They promote code organization, testability, and separation of concern. By injecting services into controllers, you keep your application modular and maintainable. App service provides a simple example of service and does not implement any complex logic. So here if you go, this attribute and decorator is telling that this class will be used by the framework and it will be automatically injected wherever it is required. In our case, it will be actually injected into the constructor of controller class above here. This may contain other logic as I've described earlier, database related or any other thing. And if I go to the controller class here, controllers act as a bridge between incoming HTTP requests and application logic provided by the app service. It handles routing, delegates the actual work to the service class here, and returns the service response to the client. So in this arrangement, we just need to attribute our class with controller. We are just attributing our method with HTTP verb like get, post, delete. Let's have a look at app controller spec. This particular class is primarily an arrangement to test our controller and it provides us a facility to unit test controllers. Now let's go to test section. We are trying to app.e2e spec.ts. This also contains unit test, but it focuses on entire application flow and from making an HTTP request to receiving response. This includes controllers, services, and potentially other parts of the application like middleware or database interactions. We are trying to create a module and then we are starting our server to listen at port 3000 or any port that is provided by .env file, and then we are calling the bootstrap method. So Nest Factory is provided by our Nest framework itself. Here we have one module that is grouping together controller and service class. And similarly, if there are any other classes that we need to have a particular feature in our application, then they will be grouped by the module syntax here. Module represent a particular feature or a business function of our application, like user authentication and authorization or the user management. So entire application is divided into different modules based on feature rather than technically dividing them into layers. Now I like to show you how we can scaffold entire feature with CRUD operations, modules, services, and everything related. Nest gResource command help us to do that, and I'll be using it to generate a feature. So I am generating it for products. So the first question is, what transport layer do you want? I have multiple options available here, like REST API, GraphQL, code first approach, or the schema first approach. Then I have microservice non-HTTP, means that I'll be communicating either using gRPC or any other protocol. Then I have WebSockets. In this particular case, I like to continue with REST API. And would you like to generate CRUD entry points? Yes, I definitely like to. I have all code generated here along with entities that I need. I can later change it to serve my purpose. I can add more DTOs later on. Basic code is generated with a controller that has post, get by ID, patch, delete. So all the CRUD operations are already there. And if I go to the service class here, I have the boilerplate or the template already generated for me. I created a Docker Compose for this project, and in this Docker Compose, I'm pulling in containers for Postgres SQL, and I'm also pulling in a container for Postgres admin that will allow me to interact with my database directly through this UI interface. And in the environment variables, I'm providing the username and password for this database and the database that I like to use, providing the port mapping and providing the volume where data will be stored or database will be actually created. Now I've created this docker compose.yml to set up Postgres and Postgres admin. This will allow me to run containers by using these images, and I will use these servers in my development. In detached mode, it is pulling from internet, so it will take some time. So our container started, and now we can work with them. NESTJS provide quite comprehensive documentation, and in this particular case, it can allow us to integrate with different type of ORMs. That includes both Prisma and Typeorm. So in this particular example, we will be using Typeorm, and for that matter, we'll be pulling in the required libraries using this command, with the difference that we will not be using MySQL, we'll be using PG. And if you go below, in the app.module.ts, we will be importing that Typeorm using this syntax that we will copy from here and paste in our app.module.ts root module. For entry creation, we will be using different attributes. For example, in our case, we will be creating customer orders and products entities. And these attributes like entity and column attributes, and wherever it requires some extra information, will be used to create entities. And there is something called relations. We will be using type ORM relations as well. And in our feature related module, we will be importing for feature like this. We'll be importing particular entity and doing the interrelationship between different classes serving the feature. And below here, if you notice that we are in our entity.service.ts, we are importing the necessary library, and we are using the inject repository here to inject the repository to interact with our database. Then we have the relations section that help us to create one-to-one, one-to-many, many-to-many, or many-to-many relationships between entities. In this case, they are mentioning that one user can have multiple photos. So the relationship between user and photos is defined here as one to many. So let's get started. Importing required packages for Typeorm. Once these libraries are installed, we will be creating entities. We have Typeorm in our dependencies now. A middleware class using npx nest gmi, and I'll be using this middleware as a logger. Here I'm receiving request and response. And use Winson logger here for Loki logging. So we are in app.module.ts and we have added our new logger middleware here after importing the newly generated class. For validation purposes, we need class validator and class transformer, and I'm installing these packages here. In Scaffolded project, I have number of changes and I will start explaining those changes from main.ts. There is only one change that I have added a global prefix for all REST API routes, and all routes will be prefixed with v1/API. The rest of the things are same, and here I am creating my root module using the next factory, and then I'm starting my express server here and finally calling the bootstrap method here. Now let's visit app.module.ts. Here I'm importing all the required modules and entities, which I'll be explaining in a moment. And then the middleware I scaffolded for logging. I've already imported the required ORM modules, and in the module section or fixture, I'm importing type ORM for root with parameters like type, Postgres, localhost, and port number, database credentials, and database name, and then the entities, customer order, product, and order item. Then synchronize true to migrate the changes to database in this code first approach. And then I have custom modules or business features like product module, customer module, and order module. We are in vertical slice architecture and we have scaffolded each of our business feature like customer orders, products. Then if we go below, we have controller for this root module, app controller, and app service. And below here, we are adding the middleware in the configure method, and we are calling consumer.apply. Consumer.apply, and then we are passing in a logger middleware for all the routes. Time to visit entities and importing the required classes from Typeorm library and attributing my entity with @entity. Then I have my primary key that is attributed with primary generated column, and UUID will be used as a primary key, universally unique identifier. And then we have index column. These two attributes are applied on customer name. So index will be generated on customer name as well for this particular table. And then we have another column, see email with unique is equal unique true. So it states that this particular column will contain all values that will be unique. And then we will have phone and address and city, postal code, and other information here. Then after that, we have date. creation date and modification date. And in extra information regarding column, we are providing the type timestamp and current timestamp as a default. And on update, we are providing current timestamp for modification date as well. And this is nullable. At the bottom, we are defining the relation that one customer has many orders, and this relation is defined using one-to-many attribute. And here we're defining the relationship between order and customer table. Now we are in DTO, data transfer object. Here we are using the library that we have imported for validation, and these attributes are primarily from our validation library. Class validator, in this case, we are not using Zord here, and we are applying this empty and string attributes as validation checks on our customer names. Similarly, we are applying the same attributes on C email, and then we have his phone number validation here. We have address and city and postal code, and with some specific fields we can use predefined attributes to check their format, like at is postal code. We can actually specify the format or we can use the default one. The update customer DTO is primarily derived from our customer DTO. Opening the order entity here, which is quite similar to the customer, attributing the entity with at the rate entity attribute. We have at the rate index. Index will be generated on both of customer ID and order date. Default index is with order ID, as it is a primary column that uses UUID. And here we have the similar arrangement for order date. And then if we go below, we have a reverse relationship many to one for with the customer table. And the relationship is on customer ID. We have the timestamp and status column, and below we have a number which is indicating the total for that particular order. And in this case, we are providing in some extra information like it is decimal and the precision is of order 10 and scale 2. This will help us in our calculations and getting more precise calculations. We have another relation with order items. One order can have many items, and we are creating a relationship with the order item table. And below, we have a boolean that is telling if the order is paid or not. And if we go to the order item entity here, I have placed the order item entity in the same folder. And here I have similar arrangement that I am defining different columns like primary key, order item ID, and then I have an indexed column, product ID, and then product name, quantity that is purchased, and then I have a reverse relationship with orders many to one. We are telling that if the order is deleted, then the associated related records will be deleted. I have order item DTO here. So in this data transfer object, I'm defining DTO along with the validation rules. And on date, I have is date is not empty and type date validation checks. And if I go below, I have UUID validation on customer ID. This customer ID is serving as a foreign key. And then if I go below, I have shipping date with is date. I'm putting an extra is not empty here that I should delete. And if I go below, there are similar validation checks. I've added a min 0 validation check on total because it can be a negative number. I have here is array, array min size 1 for order item DTO because we want to create order, but we do not want to create order without any order item. So that's why I'm putting array means size 1, and then we have at validate nested each true ensures that each item in order items array is validated. The validation is part of order item DTO. Similar DTO structures for product with validation checks and entity. So let's visit our service classes in products, orders, and customers. All of these provider classes, service classes are attributed with injectable, and they are importing the DTOs and entity and type ORM repository and inject repository from type ORM. If you have a close look at customer service here, we have a constructor here, and in constructor it is at the rate inject repository, and we are passing in the customer. This provides us the type ORM customer repository, and we have regular create, find all, find one, update, and delete methods named as remove using the customer repository. Here I am receiving the create customer DTO that is already filled by the controller using HTTP request body, and I promise a return of customer here. I'm calling a create function with create customer DTO and then return await this dot customer repository dot save, and then I'm passing in the customer. You can call this dot customer repository dot find that will return all the customers, and if I go even below you can find one, and in find one I'll be passing in the ID, and that will be mapped to customer ID, and here it will return me the record that matches the ID, or it may throw an exception that it is not found. If I go below, I have update. In case of update, I'll be calling update method on my repository, and my DTO will contain the fields that I like to update, and along I will pass it along with the ID of particular record or the primary key, and it will help me updating the record, and before returning I will find the same record again and return it back to the calling client. Remove, I have customer repository dot delete and I'm passing in ID. Now let's discuss the product feature. It is quite similar to customer feature, and in the product I have got the nest common injectable, and then I have the ORM related imports, then the repository and DTOs and entity. Here I'm attributing my product service with injectable so that I can use DI to inject it into controller. And then I have inject repository attribute for the product that will inject a product repository into my service class. And I will use this product repository to do my CRUD operations. Here I am receiving a create product DTO that is already filled by my controller by using HTTP request body, and here I'm calling create method on my product repository and passing in the create product DTO. And finally I'm calling product repository dot save method on the product to save it or persist it in our Postgres database. And in find all it's quite similar to customer and similarly rest of the methods. So the only difference we can see in all of this arrangement in order is slightly different because it has order and order items. And if I go to order controller, it is quite similar to that of service and products. If I go to service here, then you can find some differences. I'm injecting two repositories. One is order repository and one is order item repository from type ORM. And then if I get into the create method, I'm receiving my data transfer object for creating, and then I'm separating the order items from other order data. Firstly, I'm trying to persist my order data by using the create method on order repository and then calling the save method in the next call and passing in the new order. So in this section, I'm saving my order, and then after that, I'm trying to save the order items related to this particular order. Here, I have if my order item length is greater than 0, then here I'm trying to call a map method, and in this map method, I'm picking one item at a time and trying to create order item in this map, and then order item repository dot save, and I'm passing in the order item to insert, and then return save order. In remove method, we are just giving a glimpse of exception handling here. Firstly, we are trying to locate the item we like to delete by using the ID that is passed in, and then if it is found, we can safely delete that particular order. Otherwise, we can throw an exception. Update method is quite interesting because it receives ID and update order DTO that also contains order items. Firstly, if you have a close look at it, I'm using a transaction here to give an idea that how we can create a transaction. And I'm also using an alternate method to get repository by using the manager here. So the first thing I'm doing here is to separate the data in the top, and I'm separating my order data and the order items. And updating the order is pretty simple, that I'm getting the get repository order and calling the update method along with the ID of the record that I want to update and passing in the order data. In this section, what I'm trying to do is to fetch all the existing order items based on my order ID from my database and build a list of order IDs here that will help me to understand that what particular IDs I have updated. If we go one step below here, here I have a for loop, and in the for loop, item of order items. In this case, I'm iterating through all the orders that I've received in my function request in my HTTP request body. And then what I'm trying to do, I am checking if that item that I have selected in this iteration has an order ID. If it has an order ID, it means this item already exists and I have to treat it like an existing item and I just have to call an update on it. So I'm just calling manager get repository order item dot update and passing in order item ID and then item itself. Here I have the list that is serving as a scratchpad for me that contains the list of all the existing order items. And once I update one order, I remove its ID from my scratchpad and I say this particular order item has been processed. And in the next item, suppose if I pick an item that doesn't have any order item ID, then it means this is a new item and it does not exist previously. So I'll go into else and I'll create a new item and save it. So I iterate through all of these items, and finally, when all the items are finished in my order items, then the items that have been removed from my database will be surviving in my exist order items IDs. So in this logic here, what I'm trying to do, if existing order item IDs dot length is greater than 0, then I am calling manager dot get repository and I'm passing in the order item and I'm calling on delete and passing in the existing order item IDs. Finally, I am returning updated order with items here. My container services are running here and have pgadmin that I can open in my browser. I'm connected to my Postgres instance now, and if I go and start application here, it will migrate my database. And here I can find the schemas. I've got my tables, customer, order item, and product. I'm all set up for the testing now. I'm using a VS Code plugin called REST Client, and I've created REST Client HTTP file here to test my endpoints. Just to test my server function. To test my server, I'm just sending in a request to the root. So I'm getting the hello world back. So let me create a customer here. And maybe I can change it a bit. Let me send the request. And it is saying 201 created. And I'm getting back the created record here with the customer ID. And if I get copy this customer ID here and paste it here, get customer by ID and send the request. So I'm getting 200 OK. I got back my customer. Let me test this endpoint, send request to get all the customers. So I'm getting a couple of customers here, the one I created now and one I created when I was testing it. And if I go to next step, update the customer, I just want to change the address, so and the city maybe. If I include two of them here, here I'm saying ABC Street and maybe small town or XYZ town. Let me send this request. So it is 200 OK, and I have changed it successfully. And now I can test my delete on this customer. Let me copy the customer ID and I quickly paste it here. So I'm done with that. Now I send the request and 200 OK, and it means it's successfully deleted. To verify it, I'm getting all the customers here. Send request, and I got the customers. And now the array has only one customer here. Similarly, we can send requests for other routes like products. I created few products there. So I have few products here, and I can specify the product ID if I like to get a particular product by copying and pasting this ID, and I got the result. Now I'm moving to get all the products, or it's there. Now I want to create a new product, and in this case I just say mouse, optical mouse, and maybe I have 15 stock and price is like 30, and I'm selling it for something like maybe 35. So if I'm running it, I have mouse here as a new product. So I can also delete the product by passing in any ID here. Suppose if I like to delete, so if I go below, I created few orders and I can send a request to get all orders. So I have this order here. Notice that I don't have any order items because we didn't program for getting the order items. We can update the program to get order items along with the order if we like to get them. And if we go to other endpoints, we can create a new order by passing in order and order items. And similarly, we can update order items here. So let me create order here. Let the customer ID be the same. And this is another order. And I have to find and paste product IDs that customer bought. Maybe for the time being, these IDs will work. And let me send in the request. So we have 200 created. Let's go to our database. And if we go to orders here and view data, so I got the order on the top, another order. So this concludes our video here, and the only thing that we need to do in this code is to implement proper exception handling and user-friendly messages in our controller. So stay tuned for the next video with a GraphQL, and we will be using GraphQL and Prisma together with NestJS to create a REST API.